Hi, this is Mrs. Robertson, and today we are going to be doing properties of operations. This is lesson 3 from chapter 5, located on page 367. And this is chapter 5, lesson 3. Now, since we're going to be doing 2 lessons today, we're going to do chapter 5, lesson 3, and lesson 4. I'm going to skip the real world link of this lesson and go straight to 368. Let's just get into the meat of it. Properties of operations. All right. Now, well, this is how we talk about it in words, and then with symbols, and then we'll do examples with numbers. The commutative property states that the order in which numbers are added or multiplied. So it's only true for addition and multiplication. So let's put a plus sign and a multiplication sign above it so you know it's only true for those things. Does not change when with the sum or product. Okay, now here it is in algebra symbols for addition. A plus B is the same thing as B plus A. A times B is the same thing as B times A with the dot. Now, I want you to show the other way for multiplication. This is another way you're going to see it. It'll be written AB equals BA, where they put the variables right next to each other. So write that above the ones there. That's the commutative property. Commutative property, when you commute, you move. If you commute to work, that means you drive to work, you move. And look, the A and the B switch places. They move around. Everyone understand the definition of what commute means? Commute means move, and the variables, or here the numbers, move around. You all know that 6 plus 1 is the same thing as 1 plus 6. Yeah. And 7 times 3 is the same thing as 3 times 7. That's the commutative property.
Unless you divide one.
Right. And it's not true for subtraction or division.
Now if you divide for 1 times, divide by
1. You won't get the same thing.
No?
You know, 6 divided by 1 is 6.
No,
1 divided by 6 is...
No, 1 divided by 1.
We'll talk about that later, but I got to keep going. Okay. Associative property. Now, the associative property states that the way in which numbers are grouped, it's a grouping one, when they are added or multiplied, does not change the sum or product. Once again, it's only true for adding and multiplying, when they're all adding or when they are all multiplying. Okay, now, this is my story for associative. Commutative, I gave you the story of commuting. Associative has 2 S's. The S's are like little snakes. They slither around, and they are your grouping symbols. Associative property has the grouping symbols, and the grouping symbols move around. Okay, they're like little snakes. The snakes are grouping symbols, and they move around. All right, that might be a helpful tip. It doesn't have any mathematical background. It's just a little story to help you visualize the S's turning into snakes and moving around. So, symbols, what does it say? A plus in parentheses B plus C will give you the same answer as A plus B in parentheses plus C. All right? Multiplication, let's show it this way. A times B times C equals A times B times C. That's another way to write it without the dot. Everyone have that written down? Good. Now, when would we want to do that? Well, sometimes, like in this one, it's easier to do 4 times 5 is 20, and 20 times 3 is 60, than 3 times 4 is 12, and 12 times 5. It's still 60, but sometimes it's easier to do things in your head if you can move them around. And these are the rules that allow you to move things around. All right, a property is a statement that is true for any number. The following properties are also true for any numbers. Okay, the additive identity property. Well, that says when you add something to this number, it keeps its identity. What is it? It's 0. A plus 0 equals A, and 0 plus A equals A. So does everyone see the additive identity property? Now, could that be the same for multiplying? In multiplying, instead of 0, what keeps your identity in multiplying? Multiplying by 1 keeps its identity. Okay? Does everyone have a relationship now to what the additive identity? What do you add to something to keep its identity? What do you multiply something to keep its identity? Okay. Now, the multiplicative property of 0, it just means when you multiply something by 0, you get 0. Those are not hard. So we just went through 5 properties rather quickly. The commutative property, the associative property, additive identity, multiplicative identity, and the multiplicative property of 0. Now let's look at some examples and practice these properties. Name the property shown by the statement. Okay, the first thing I do the numbers move or do the parentheses move? 2, 5n, 2, 5m. The numbers did not move. The parentheses moved, so it is the associative property, and they're multiplying of multiplication. Any questions on that? Let's look at letter A. 42xy. 42yx. What property is that?
Additive.
Commutative. The numbers moved around, or actually it was the variables moved. So it's the commutative property of addition. So I just put prop addition. Okay, otherwise it won't all fit on there. This one, 3 times x plus 0 equals 3 times x. Its identity of addition, yeah, it kept its identity. 3x kept its identity because when you add 0, that's the additive identity property. The additive identity. All right? Any questions? Let's go on to the next page, 369. It says, you may wonder if any of the properties apply to subtraction or division. If you can find a counterexample, an example that shows that a conjecture is false, the property does not apply. And it doesn't work for subtraction or division, kids. Now let's go to example 2. State whether the following conjecture is true or false. That's a statement. If false, provide a counterexample. Okay. Division of whole numbers is commutative. That is false.
Because you can't do it.
All right, because 15 divided by 3 does not equal 3 divided by 15. Why? 5 does not equal 1/5, does it? No. And that's all you have to do to prove that it is not true. All right, let's look at letter C. The difference of 2 different whole numbers is always less than both of the 2 numbers. All right, so the difference of 2 numbers, let's say 5 minus 3 is always less than both of the 2 numbers. I think they mean the sum of the 2 numbers. Well, if we do 3 minus 5, we know that's not true because 2 is not less than a negative 2. On that, let me just check the book to see what they exactly wanted. I could see 2 or 3 different possibilities. And on that example, yeah, they had 8 minus 2 equals 6, and 6 is not less than 2. I don't really like, this isn't something that'll be on your test. I think that's confusing. All right, number 3.
So it was yes?
That one, just leave it blank. It's confusing. It's no, it's not a true one. It's false. It is false. Number 3. Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. All right, kids. This is what you do in your mental math. Today, we will justify your mental math steps, which is, none of you like to justify your steps, but we'll only do it for some of the problems. But I have to show you why you're allowed to do things mentally. Okay, commutative property. They move things around. Why? This is friendly and this one's friendly, isn't it? Because they'll give you, this will give you 60 and that will give you 30, right? So first they move some numbers around. When you move them around, that's the commutative property, okay? Then they put grouping symbols in. When you put grouping symbols in, that's the associative property. Then you add and you get the answer is called simplify. All right? Yes, you'll have to do a couple problems like this, but just a couple. All right? D. Lance made 4 phone calls from his cell phone today. The calls lasted, they've got them listed. Use mental math to find the total amount of time he spent on the phone. Well, my mental math kids, I know you're going to take 10 and 6/10 plus 9 and 4/10.
That'd be 20.
And I'm going to go ahead and then you're going to do 2 and 3/10 plus 4 and 7/10. So we did the commutative property, right? When I wrote it down, I did the commutative property. Then I put in the parentheses. Then it was followed by the associative property. Then I add, and then we'll get the answer. So when I add this one, I get 20. And this one, we get what, 7?
Yeah.
And then the answer is 27. And that's simplifying, that's the answer.
It's not that hard.
Simplify. There, got the F in there. Okay, now let's go to page 370. In page 370, if it's an emergency, take the pass. We're doing the same thing again. Simplify each expression. Well, we don't know what G is, kids. But we can simplify, we can combine 7 and 5, okay? So you move them around with the commutative property, then you put the grouping symbols, and this is your answer, G plus 12, all right? It's an expression, we don't get an exact answer. Later on we'll do equations, and then you do get exact answers. Number 5, here, I'm going to move things around. I'm going to get the 11 over here. Then I'm going to move my parentheses around. 11 times, what's m times m? M squared. Do you see how they did that? M times m is m squared. Do you see how they simplified this expression? Okay. Now, I want you to do letter E.
I'm already
So I'm going to move things around.
Oh, yeah, I forgot the 2.
You have to write down. So you're going to have the commutative property. So then I will have 4 times 2 times 3c. Then I move my parentheses, so that's the associative property. Sometimes I forget, I just put the first 3 letters, but then I realize I wrote a bad word. If I do that, I don't mean to do it on purpose, but don't just put 3 letters for associative. It doesn't look very nice on your paper. Then you have 8 times 3 times c, and then on that one, it can be simplified again because 8 times 3 is 24. You end up with 24 times c. All right, so it's the commutative, associative, you simplify, then you just, it's commutative, associative, then we simplified, then we actually do associative again because we regrouped that, and you end up with your final answer. So that one really had a lot of steps. Okay, let's go to the guided practice. Kids, which property is this? When you end up, yeah.
It's multiplicative property of 0.
Right, it's the multiplicative property of 0.
Can we just write prop 0?
Multiprop of 0. Okay, because it is only true for multiplication that it ends up with 0. What's the answer to this one? Identity property of? Right, that one's the identity prop of addition. Okay, any questions? State whether the following conjuncture is true or false. Subtraction of whole numbers is associative, kids. That is false. And a counter example would be 5 minus 3 minus 2 does not equal 5 minus 3 minus 2, where if I had the parentheses here and then I had it here, because 2 minus 2 is 0 and 5 minus 1 is not 0, is it? They don't equal. So this would be 0 does not equal 4. Now we're going to do number 4. We're going to justify our steps. Okay? So the first one is usually commutative. I'm going to move things around. I'm going to have 9c plus 3c plus 8. That's commutative. I moved it around. Next one I'm going to do is the associative property, because I'm going to move my parentheses. 9c plus 3c plus 8. If the pass is back, then you can. I don't see it back on my desk. So 9c plus 3c is 12c plus 8 is your final answer. You can't add the 12 to the 8 because it's multiplying. Go get it. Any questions? Okay. Now, we're going to go on now to the distributive property. So right now, I want to make sure you're all good with, you know, the commutative property for addition and multiplication. Whoops, let me make it so you can see it. You all know the associative property for addition and multiplication. You know the identity prop for addition. You know the identity property for multiplication. And you know the multiplicative property of 0. Sometimes it's just called the 0 property. Okay? You have 5 of those, and we're going to add one more. And this is the biggest one, the distributive property. So now we're going to go on to the next lesson, which is on page 375. The distributive property. Okay? Now we're going to go to page 376, because that's where it talks to you about what the distributive property is. Now this one's really important, and if you can wait and not go to the bathroom till I'm done telling the distributive property, I would prefer that, and then you can go. Okay, the distributive property states that to multiply a sum or difference of a number, multiply each term inside the parentheses of the number outside the parentheses. Now, my story on the distributive property is called the grandma property, because I'm a grandma, and I'll go into it in a little more detail. First, let's look at how they would communicate it in algebra. A times B plus C equals A times B plus A times C. This one works for subtraction. A times B minus C will give you the same answer as A times B minus A times C. Let's look at examples. 4 times 6 plus 2. Well, 6 plus 2 is 8, and 4 times 8 is 32. This will equal 4 times 6 is 24, 4 times 2 is 8, 24 plus 8 is 32. And we have happiness. It works for subtraction. 7 minus 5 is 2. 3 times 2 equals 3 times 7 is 21, and 3 times 5 is 15. 3 times 2 is 6. 21 minus 15 is 6. And we have happiness. All right? Now, why do I call it the grandma property? Well, this is why. I'm going to look at this. A is grandma. B and C are her grandkids. Now, it works for more than just two. Let's do an example over here. Let's do A times B plus C plus D. Okay? Going to have, that's the same thing as grandma gives B a present, AB, plus grandma gives C a present, AC, and grandma gives D a present, plus AD. Do you see how that works? Grandma has to give each one of those kids a present, or otherwise her grandkids aren't going to love her. And she wants all of her grandkids to love her.
That's greedy.
Oh, sometimes all it has to be is something like a piece of paper that has something on it. Now, they're all different ages. But if I give Hattie something, then Lois wants something, and Otto's not quite old enough to figure it out yet because he's 1. But in another year, then Otto will know if he doesn't get something. So it's like I have to make sure I give Hattie, Lois, and Otto all things to keep them happy, because I want them to love their grandma. Or I'm called Mama, which sort of sounds, not my choice, but the grandkids pick what they call you. You can't make them call you what you want.
My grandma, and my grandma, my other grandma, Grammy.
Grammy. Okay.
One of my grandmas is named Grammy. The other one.
Yeah, you all come up with your own names for your grandparents. Okay, now let's look at our examples down below. Okay, so I want to do these problems A, B, and C where we show the visitation. Okay, now we're just practicing on this. This will equal 5 times negative 9 plus 5 times 11. Okay, this one, 7 times 10 minus 7 times 5. Now I guess we could go ahead and simplify it. That would be negative 45 plus 55, and you end up with 10, which negative 9 plus 11 is 2, and 5 times 2 is 10. Sometimes it's just easier to do it this way, but later on when we have our variables, you've got to know how to do this to simplify our expressions. Now, yeah, it'd be easy, 7 times 5 is 35. Let's see if we get 35 here. 70 minus 35 is 35. Now this one, it's still the same. This is the grandpa. He's over at the back end instead of grandma at the front end. You do the same thing. It's 9 times 12 minus 9 times 8. Or it could be 12 times 9 minus 8 times 9. And here you end up with, 108 minus 72. And you end up with, 36? 12 minus 8 is 4. 4 times 9 is 36. All right. Now let's go to page 377. Use the distributive property to rewrite each expression. This is when we really have to start using it. We're going to have negatives. Down here we have double variables. See how we're going to work our way up to example 6? Let's go. Okay. Step 1, 4 times x plus 4 times 7. And the simplification of this is 4x plus 28. Okay? Or we rewrite an expression that's the same. So this is the same thing as 4x plus 28. Do you see how to rewrite it that way? Sometimes you'll want it this way, and sometimes you'll want it this way. All right, let's do number 3. Let's put equals. It's going to equal, now, this is important. Rewrite p minus 5 as p plus negative 5. It just makes it, you just want to do that. So, let's do that right now. Add a negative 5. Did everyone do that?
So add the opposite?
Add the opposite. Change your subtraction to an addition. Now we have 6 times p plus 6 times negative 5. All right, that's that level here. And then you have 6p plus negative 30. Now, you are rookies, so I would count both of these right. This and this say the same thing. On your test, if you wrote that for your answer or this for your answer, I would count them both right now because you are rookies. Now, in May, I'll be more specific, but you're just learning about this and I don't want to be real, I can give you a little leeway on this step, okay? Now let's go to number 4. All right, step 1, get rid of your subtraction sign. Add the opposite. So you'll have negative 2 times x plus negative 2 times negative 8. See that? That'll be negative 2x plus negative times negative is positive 16. Any questions? Are you able to see the screen okay? Now let's go to number 5. It's going to be 5 times, here we have 2 variables, but it's not a big deal. 5 times negative 3x, right there, circle it, plus 5 times 7y, circle it. 5 times negative 3x is negative 15x. Do you see that? 5 times 7 times y is 35y. Do you see how this simplifies into that? Okay. One more example, and then I'm going to see if you really know how to do this. It works for fractions too, kids. You take, step 1, get rid of your subtraction sign. Add the opposite. Did everyone do that? Okay. Now you're going to have 1/3 times x plus 1/3 times negative 6. 1/3 times x, plus 1/3 times negative 6. Well, 1/3 times negative 6 equals negative 2. And your answer would be 1/3 x plus negative 2 or 1/3 x minus 2. I would count both of them correct. Okay, now I want you to do D, E, F, and G over here. So over to the top of your paper. Letter D will go up to the top in the green area. You're going to rewrite that one. I'll do this one for you. You would write 6 times A plus 6 times 4. Simplify it. It will equal 6A plus 24. Final answer. Any questions on what I want you to do? Okay, go ahead and do E. Then do F and G. I will go through and give the answers to these in just a moment. So for letter E, you should have had 8M plus 24N. In letter F, I have negative 3 times y minus 10. Oh, I must change that to an addition problem before I go any further. Add the opposite. That's kids make their mistake right there. They forget to change the subtraction to an addition. So, negative 3 times y plus negative 3 times negative 10. That will equal negative 3y plus positive 30. Any questions? Negative times negative is positive. Letter G. We're doing the same thing with the fraction. Change your subtraction to an addition sign. Add the opposite. You're going to have 1/2 times W plus 1/2 times negative 4. So you'll end up with 1/2 times W. Half of a negative 4 is negative 2. Or another way, 1/2 W minus 2. You're rookies, so I would count either one right. Any questions?
No.
Okay, now let's go to, yeah. E, 8m plus 24n. N. Okay, now we're going to go to page 378. Any other questions on E, F, and G? All right. We have a word problem. How to apply this to word problems. Mr. Ito needs to buy batting helmets for the baseball team. The helmets he needs to buy are $19.95 each. Find the total cost if Mr. Ito needs to buy 9 batting helmets for the team. Well, it says let's just rename $19.95 to $20 minus 5 cents. So this is one of those things they do mentally sometimes. Then use the distributive property to find the total cost mentally. You're saying, this sure looks like a mess if you're to do this in your head, but when you do things mentally, it does require a lot of steps that you are not realizing you're doing. All right, so that'll be 9 times 20 minus 9 times 5. Now, here we like to add the opposite, but when you're doing it mentally in your head, they didn't have you change it on this one. You know that minus 45 cents is the same thing as adding a negative 45, and you end up with $179.55.
Would you just give me $19.95 times 9?
Yes, and normally you would. On the word problems, unless it's specific on there, I usually don't care which way you do them. All right, that was just an example of one. Let's go on now to page 378. We're going to skip example H and go to page 378. Use the distributive property to evaluate or rewrite each expression. So number 1, you're going to have negative 3 times 8 plus negative 3 times 11. That's what they want you to do. And, oh, I'm on the wrong page here. You'll end up with negative 24 plus negative 33, which equals a negative 57. Negative 24 plus negative 33 equals a negative 57. Yes, 8 plus 11 is 19, and negative 3 times 19 is also negative 57. I think that's easier than doing this, but we're practicing the distributive property. This one, negative 5 times 2x plus negative 5 times 4y. Okay, so negative 5 times 2 is negative 10x. Plus negative 5 times 4 is negative 20y. Now, we cannot combine an x and a y because they're different terms, okay? You cannot take negative 10x plus a negative 20y because this is your final answer. They are two different variables. Now, if they were the same variable, you could add them together, but they're not. Okay, this one, let's get rid of the subtraction sign. Add the opposite. 1/5 g minus, or excuse me, plus 1/5 times negative 10. Well, 1/5 G is simplified, right? So you just keep that 1/5 G plus 1/5 times negative 10 over 1, that negative 2. So another answer for that could be 1/5 G minus 2 or plus a negative 2. Okay? Let's look at number 4. A housefly can fly about 6.4 feet per second. At this rate, how far can it fly in 25 seconds? They want you to use the distributive property, and this is what they want you to do. 25 times 6 plus 4/10. 6.4 is 6 plus 4/10. So you'd have 25 times 6 plus 25 times 0.4. And then you get the answer. 25 times 6 is what, 150? And 25 times 4 is 10. So you have 150 plus 10 equals 160. Now, what do I want you to do for homework today? All right, so for your homework today, I want you to do page 379. Yeah. And I don't think I want you to do 378. No, we're not going to do 378. And we need to go back, and the properties paper is really easy. I want you to do page 371. Now, on page 371, I want you to do 1, 2, 3, 4, 5. We're not going to do number 6. I want you to do 7 and 9. Okay? 1, 2, 3, 4. You just write down the answers. 5, you give an example where it's not true. 7 and 9, you do have to justify each step. So just put which property you use. It's usually the commutative property, then it's the associative property, and then you add, or in this case, you'll probably multiply. Okay? So that is your assignment for today.